All right, looking at this elastic solvent's solution solubility curve. Looking at question 1. All right, so question 1, we got 3 things we got to do. We got to put an answer here, here, and here. Is that all of them? All right, now, so we're using this graph to answer our question. First one is asking us what type of solution is formed. Is the solution saturated, unsaturated, or supersaturated? So we're going to look at the KCl line. Only looking at this KCl line. We're going to plot 50 grams here and 100 grams of water. So we're in 100 grams of water at 50 Celsius. So we're going to plot this one and this one. We're going to compare it to this line to figure out what we got going on. Now for the bottom two, which one's the most soluble at 0? Which one is the least soluble at 0? We're going to pick one of these. Right? Only looking at above 0 degrees. Right? Only above 0. So is the line that has the most solute in it is the most soluble. The line that has the least solute in it, only at 0. None of this other part matters, only at 0. All right, so again, we're going to compare. This box is above the solubility line. This box is talking about being on the solubility line, and this box is below. So based on that, pick these 3. All right, so as it says, you haven't taught this. We are going to learn how to do this next semester. So it's kind of like a little preview. But what you should be able to do is to look at the name and find these symbols on the periodic table. So you know potassium is K. You're not going to find iodide, but you will find iodine. So something similar to your second name, and you should be able to pick out which one goes there. So use your periodic table to try to find these. All right, so this one, we're going to pick out one of these statements explains what this graph is doing. So remember, look at your temperature. So my temperature is what, 10, 20, 30, 40, 50, moving this way, right? And my solubility is getting bigger going up. So look at this line, try to figure out what does this line represent based on temperature and solubility. All right, pretty self-explanatory. We're just going to match these, okay, with the correct definition. All right, correct definition. All right, so which one is the most affected? So out of all of these lines, all right, you compare the temperature and their solubility. You want one that is affected the most. You want one that changes the most based on the temperature change. Now it can change going up, it can change going down. It doesn't matter. It's like a slope thing, rise over run. Which one has the highest slope? All right, so this is kind of the opposite of that, the one that is least changed. So as we change temperature down here, what do you expect the line to look like if something is not affected? All right, so now the answer to this is not a gas. It's not a gas. I don't want you going home and thinking that whatever this answer is a gas, but it's not. But we're trying to find which one is most likely to be a gas based on how it responds to increasing the temperature. So the one, as the temperature goes up, we're looking for the one that starts dissolving worse, right? That does not do as good, maybe less solute. All right, this one here, you're going to type in, right, saturated or unsaturated or super saturated based on when you plot these points on this graph. Is it above, on, or below that line? Question 10. All right, so this one, all right, we're going to use this graph. This is very important. Type in a numerical answer with no decimal places or anything like that, just a straight up whole numbers for items 1 and 3. So for 1 and 2, right, your answer will either have a 0 or a 5 on it. Answer 3 will not. It could be anything 0 through 10. So all you're going to do, we see this 100 grams of water. All that means is that the solvent is 100 grams of water. All right, so you're looking at 30 degrees Celsius for potassium chloride. Again, you don't know what potassium chloride may look like, but you know the symbol for potassium is K. what is the symbol for chlorine? So that kind of helps you identify your which line you're using. So you do that for 1 and 2. Number 3 is a little different. So you do it the same thing, right? You find this one. This is potassium dichromate at 50 degrees Celsius. So 50 degrees Celsius, here's my potassium dichromate. So you look and see at 50 how much solutes here. Then you got to think, all right, you already got 12 grams. So how much more do you need to get to this point here? All right. Finally, it says identify the solvent of the solubility curve. All right. This is the solvent. Okay. This is the solvent. Always remember that. Now, do not write this in. Write the name of this. Don't write in this as it appears. Write the name. All right. So when you're looking at this one, remember these things we did in our lab. We did a lab on this with the sugar cubes. What makes it go faster? So the more things we do, the faster it can dissolve. So think about that as you go through and you check this question out. So all of these things is what we mess with our lab, but only one of them, all of it makes them go faster. Only one of them changes how much you can actually put in there. All right, one of these statements is not true. All right, check it out, figure it out. Finally, use the solubility curve below to identify how much KNO3 potassium nitrate will dissolve into 100 milliliters of water. So this 100 milliliters of water, that is our solvent. That is our solvent. Hint, hint, hint. Okay, so use this solubility curve if you can. Identify how much potassium nitrate will dissolve in at 70 degrees Celsius. All right, that's all of them. Let me know if y'all need anything else. Pause.